Thank you very much. And my name is Peng Lin from Rijkswaterstaat. A very strange name. It's from the Dutch word. And I'm data specialist. And today, on behalf of Router Clients, we're going to talk about how does the digital twin help Rijkswaterstaat to support the decision making. And before coming to the topic, I would like to give a short introduction about what is Rijkswaterstaat. It is the executive agency of the Dutch Ministry of the Infrastructure and the Water Management. And we have 9,000 colleagues managing 140,000 kilometers and also 4.4 thousand waterways and also 35,000 kilometers of the cycle paths. And I would like to show you small videos about the digital twin in Rijkswaterstaat. It is in Dutch, but I will translate it into English. In Rijkswaterstaat, we have a digital twin system, and in 2030, we are going to put all the infrastructures into the digital twin systems. The digital twin system will include all the key information of the infrastructures, and it will help us to make the decisions. The digital twin system, including all the data from different resources, to help us to visualize it in 2D and also in 3D. And with this system, we can combine it with some different data sources. It has several advantages. Firstly, we can see different material components and the structures from the map, and meanwhile, we can combine it with the monitoring sensor data, and also include the traffic and the weather data into the one system. In that way, we can build one data lake, which is very helpful for our data analysis. Based on recent AI technology, we can build a lot of different prediction model for different infrastructures, and it will help us to make the decision to find the balance point for the economic, society, and also the environmental. And based on this, and today I will give an example about how could we make the decisions based on this digital twin system. I will give the example in following four aspects. First is about how could we make the strategy planning. Amsterdam Rhine Canal is one of the busiest canal in the whole Europe. And when we face and when we want to do the maintenance for this canal, there's a big challenge because we have to take 5 aspects into consideration, including the water level, the infrastructure, the sediment, ecology, and also climate adaptation. But it is really difficult to quantify the influence of the different aspects. So to meet this challenge, we built a digital twin system, which is called WFD, which is developed by the WL Delft. With this system, we can evaluate different design scenarios without digging into the ground. And based on this system, we finally found the balance point of different stakeholders and optimize the design. And finally, it was a very successful project. And the second example is about crisis response. We take the Maasland barrier as an example. It is the biggest barrier all over the world, and it is very important because once there's a failure, the west of the Netherlands will be underwater. For this barrier, it opens every 7 years. And the challenge is that it's really difficult to monitor it when it has component degradation, and also because of the environment is changing every year, the weather, also the weather changing is happens all over the world. So the biggest risk for this project is that it is not something happens, but we don't realize that it is happening. And once if we don't have the digital twin network, maybe we will fail to react when it matters most. So for this project, we also built a digital twin system for it. It is based on the real-time monitoring, and it integrates 3 models, including the hydraulic model, the pump discharge, and also the failure probabilistic model. And it helps us to make decision when shall we open the barrier and when shall we exchange the components of this barrier. And the third example is about digital twin for the road maintenance. For the road network in the Netherlands, we have a specific system which is called beam permanency, and it helps us in these 4 aspects. But the key component is the key challenge is about real-time monitoring. How could we monitor the road infrastructures, the condition of the road structures frequently? And our solution is that we monitor the surface layer of the pavement with the LCMS system, which is laser cracking measurement system. It helps us to monitor the rutting, and also the cracking of the road. And we also combine the FWD and the TSD measurement system to monitor the health condition of the structure. And based on all of these conditions, we can use a table to determine how many years after shall we do the maintenance. And in this way, we can distribute our budget for different part of the highway. And another example is about how could we optimize the maintenance. Because in the Netherlands, the biggest challenge is the raveling. And as we all know, that's for the road, we have different lanes. And on the right lanes, the traffic load is always a little bit higher. And so the development of the routing on different lanes is not homogeneous. And in this way, the maintenance will be a big challenge because we cannot do the maintenance for the whole road. To solve this problem, we fully use the digital twins data, and together with the AI model, we had a project which is called LAM. We built the prediction model for different lanes, and in this way, we can know how does the routing develop for the different lanes. And afterwards, for the right lane, we can use a pre-maintenance method to extend the lifespan. And in this way, we can optimize the maintenance timing for different lanes. And in that way, we can make the maintenance more efficient and more economic. And thank you very much. This is my short presentation, and hope to discuss with you.
So our first question, Peng Lin, is for yourself, which says, the digital twin for maintenance looks promising, especially since the organization is clearly bought in and using it in operations. How open is the data output for this digital twin expected to be? Is it for policy and contractor use only, or for the public?
Thank you very much for this question. Data sharing is one of the most important questions, and currently we separate our data in 7 different levels, and for different level, the opening degree is different. Some is open for the public, but some of them is shared only with contractors, and some of the data is only used for separate department.